Hi, this is the presentation of our signals and system assignment. And this is group 6, which consists of 5 members, which are Goh Junwon, Koo Yueyang, Shantai Jie, Salem, and Tae Kai Wei. So this assignment consists of 2 tasks, and this is the first task. So without wasting time, let's look at the first question. For the first question, we have developed a MATLAB program of signals in the question. So we came up with these overall codes. So let's look at the codes line by line. The first 2 lines are clear function and CLC function. Next line that start with T is to declare the maximum range of time, and next 2 lines we use the head v side step function. So after having the function of the graph, now we plot it. The first line subplot 611. Next line we use plot function. Next is axis. Next 2 lines are y level and x level function. Therefore, a triangular graph with all the elements inserted will be produced. Then, we plot the rectangular graph with the same way. Then in these lines, they are not much different, but we plot a new thing called z, which we equal it to x1 plus x2. Then the graph will look like this. Then for these, it's also similar, but we equal y1 to x1 times x2 and y2 equal x2 times x1. These 2 graphs will be produced, which we can clearly see that the sequence when we multiply 2 things doesn't matter. Lastly, we equal y into the convolution of x1 and x2. Then we get a graph like this. I will have my teammate Yueyang to explain them.
Hi everyone, my name is Koo Yueyang and I would like to discuss about task 1 part 2 and task 2 part 2. So from task 1 part 2, the question asks to find zt from x1t plus x2t. So from the graph given, we can get this is x1t and this is x2t. So x1t is a triangular wave and x2t is a rectangular wave. So we can get this graph by seeing before -1 we can get is 0 plus 0. So before -1 here is 0, here is also 0. So 0 plus 0 is equal to 0. So here is 0 until -1. So -1 until 0 is 0 plus 1 equal to 1. So from -1 to 0, here is 0, and here -1 to 0 is 1. So 0 plus 1 is equal to 1. So the wave form is like that. So from 0 to 1 is 2 plus 1 equal to 3. So 2 plus 1, we can go here. Here is 2 and here is 1. So 2 plus 1 is the waveform will go up until 3. So we reach here. And then from 1 to 2 is here 2 plus 0 equals to 2. So from 1 to 2 here is 2 and then here is 0. So we can get like this. So the waveform is like that. And then after 2 is 0 plus 0. So after 2 is here 0 and then after 2 is 0. So 0 plus 0 is equal to 0. So the waveform will be like this.
I will be explaining about question 3 of task 1, which is a convolution between x1, the input of the LTI system, and x2, which is the impulse response of the LTI system. x2 undergo time reversal and also time shifting to obtain x2 t minus tau. T minus 2 and t is obtained. In case 1, which is t is smaller than 0, no overlapping between the 2 graphs occur, so there will be no integration occur. In case 2, when t is greater than 0 and also smaller than 1, there will be overlapping of the 2 graphs. Thus, integration occurs and the result will be t squared. In case 3, which is t greater than 1 and smaller than 2, complete overlapping between the two graphs occur, thus there will be integration, and this will be the result. In case 4, when t is greater than 2 and smaller than 3, there will also be overlapping between the two graphs and integration occur. This will be the result. In case 5, when t is greater than 0, no overlapping between the two graphs occurs, so there will be no integration. And this is the final result of the convolution. The convolution will start at -1t and t end with t equal to 3, with the peak of 2 at t equal to 1, which is proven true by our MATLAB code that start with t equal to -1 and end with t equal to 3 and peak at t equal to 1 with amplitude of 2. Thank you.
Hi, it's me again, Kai Wei. So let's look at the first question of task 2. For the first question, we came up with these overall codes. Similar to task 1, we used the clear and CLC function to clear our workspace and all the text from the command window. Then, the line started with t is to declare the maximum range of time. Next line, we use the head-v-side function to define g. After having the function of the graph, we plot it. So the first line, subplot 611. Next line, we use the plot function tgb. And next is axis -1, 3, 0, and 2.5. Next two lines are y level and x level function. Therefore, a triangular graph as shown with all these elements inserted will be produced. Then, we plot the rectangular graph with the same way. And next, in these lines, they are not much different, but we plot a new thing called z, which will equal it to h plus g. And the graph will look like this. And next, it's also similar, but we equal y1 to g times h and y2 equal h times g. And these two graphs will be produced. Lastly, we equal y into the convolution of g and h. Then, we get a graph like shown in the right side. I will have my teammate again, Yue Yang, to explain them.
Okay, let's continue task 2 part 2. So task 2 part 2, the question given is to find zt. So zt is equal to gt plus ht. So we can get this waveform by looking at the graph given. This is gt and this is ht. So gt is a triangular waveform and ht is a multiple rectangular waveform. So from here, we can see that before -1 is 0, here is also 0. So 0 plus 0, we will get 0. So here is 0. And then from -1 to 0, is this waveform and also this waveform. So these two waveforms add together, we will get this waveform. So from 0 to 1 is 1 plus 0. So from 0 to 1, here is 1 and here is 0. So 1 plus 0, the graph will start from 1 to 2. So here is 1. So from 1 to 2, here is 0 and here is 1. So 0 plus 1, we will get 1. So after 2 is 0 plus 0. So after 2, here is 0. Here is also 0. So 0 plus 0, we will get 0. So we will get a waveform like this. Thank you.
Hi, I will be presenting task 2 question 3, which is the convolution between gt and also ht. The symbol here represents the convolution operator. And this is the graph for gt and this is the graph for ht. As you can see, gt is the input of LTI system and also ht is the impulse response of the LTI system. Hence, ht undergoes time reversal and also time shifting to obtain ht minus tau graph. t minus 2, t minus 1, t and t plus 1 is after undergoing time shifting and also time reversal. For the first case where t is less than -1, both graphs doesn't overlap with each other, hence we get yt equals to 0. And for second case, where between -1 and 0, we get an overlapping between two graphs. That's why we will have an integration undergoing, and we will obtain this result. As for case 3, when t plus 1 is between time 0 and 1, we get full overlapping of the first rectangular block with gt. Hence, we'll undergo two integration where the limits are from t to 0 and also 0 to t plus 1 to obtain this result. For the fourth case, where t plus 1 is between time 1 and 2, we'll get two overlapping also, which is from the first rectangular block and also second rectangular block to obtain this result. For the fifth case, between time interval 2 and 3, second rectangular block is fully overlapping with gt graph from t-2 to 0 and also from 0 to t-1. That's why we also have two integration undergoing to obtain this result. And for the sixth case, a part of the second rectangular block from ht is overlapping with gt. That's why we only undergo one integration at that time from t-2 to 1 to obtain this result. And for the last case, which is t larger than 3, no overlapping between both graphs. That's why we obtain yt equals to 0. As you can see, this is our manual calculation graph that we've drawn. The starting point is from -2 to 3, and the first peak is at 3 and also 1.5, which is the same as our MATLAB report, where we obtain the same graph, which proven that our calculation is valid and also true. That's all from me. Thank you.